This is the second of the lessons on measurement that we're going to look at. This one's a review of perimeter. So much of the work we're doing on this unit is things you've seen in grade 8, but there is a little bit of new content as well. Our learning goal here is that we use our knowledge of units of length to calculate perimeter and apply it to a variety of shapes and practical applications. So perimeter is the distance around the outside of an object, and that's the key here, is it's outside. Even though a lot of our diagrams have lines and things inside the shape, it's only the distance outside. Think of it like a big paddock that you're walking around. The big key that we need to remember is that we need to be in the same units. You can't work with mixed units. You can't have centimetres for one side, meters for another, and millimetres for a third. It has to all be the same units, which is why we learn about unit conversions, to make sure that we do it in the same, have it all in the same unit so we can calculate it correctly. So these are the formulae that you know. Most perimeter for shapes don't have any formulae as such, but there are three here that you can learn. Perimeter is basically only works for regular shapes, so if you want to use a formula. So this is the square. Square has sides of L. Sometimes you'll see it written as S. So, and all four sides are the same. So logically the perimeter is the addition of those four sides, or more completely, 4 times S or 4 times L. The perimeter of a rectangle, because the opposite sides are the same, we have 2 of each of those. We have 2 L's and 2 widths. So if we add up one pair of sides and we double it, we get the perimeter. Now there are 2 versions for a circle, depending whether you have a diameter or radius. The formulas are pi times diameter. We often write it with a big D, but it's not that big a deal. Or 2 pi times radius, because 2 times the radius gives the diameter. Now, this is probably the most common one that we tend to use, but this one here is a very important one because it describes the relationship between the circumference and the diameter, which results in pi, because pi equals the circumference over the diameter, and many of the mathematicians in history use that to calculate a value of pi. Interestingly enough, by measuring the circumference of various circles and the diameter across the circle, you divide them, you always end up with the same value. And that's what pi is. So let's move on. So here's a worked example. This is just a triangle. Do a quick check. Are our units all the same? Yes, they are. They're all in millimeters. So for a triangle, we're just adding up those 3 sides. If it was an equilateral triangle, we could have multiplied by 3. 23 plus 45 plus 40 is 118 millimeters. Don't forget your units and make sure they're the right unit for perimeter, area, or volume. So for a circumference of a circle, this one here is the radius. So what we start with is r equals 2.5 in our formula. Now we do notice that we've been given some extra instructions, 2 decimal places. So on a calculator we need to round to 2 decimal places. So circumference equals 2 pi r. We always start with the formula. We always substitute for the formula. There's our radius. And then we solve. So any measurement question has 3 lines of working. That's our communication. The rule, the substitution, and the answer. Don't forget our units are in centimeters this time. This is a slightly more challenging question. The first thing you need to do here is identify what we're asked to do. So we're after perimeter, 2 decimal places. So in this case, we recognize that we have 3 different pieces. So let's look at those first. We start with this shape here. Now it looks a bit like a square, but if we look at those units, we see they're not the same. So that means it has to be a rectangle. Then we have these 2 shapes in the end. That's a semicircle. And that's a semicircle. Now 2 semicircles make a whole circle. So we can put them together if we like to make a circle like that, with a diameter through the middle of 25 millimeters. So we can work out the perimeter of the circle there and just add that on. Now one of the most common mistakes that students make here, bear with me, is that they think these two sides here get added on. They're not on the outside of the shape, so we don't add them. So the only thing we add on as far as our perimeter are these two sides. So I'm going to change the color here. Let's change it to blue. So we need to add up this bit, and then these two sides. So that's our perimeter. Let's look at the formula. So for the circle, it's pi times diameter, like we talked about. And the diameter is 25. So pi times 25 is 78.54. And then we have the two sides from the top and bottom of the rectangle, 23. So we add them up. Perimeter equals all the sides on the outside added together. So there's our circle's circumference plus 23 plus 23 equals 124.45. It is possible, if you want to do it like this. So a semicircle equals a half pi times diameter. And work that out, and then double it or add them up twice. That's a longer way of doing it. So we're looking for shortcuts. Alright, sector is a little bit different. So most of us have looked at these sorts of questions before. So there's a quarter of a circle. So the curved part here is a quarter of the circumference. So we work out the circumference, divide by 4. For shapes that aren't those nice neat quarters or fractions, what we do is look at what fraction of the circle we're talking about. So the angle here is a fraction out of the entire circle. And that's a pretty bad circle to draw, but hopefully you get the idea. So we'll work out what fraction of the circle we have, and multiply it by the circumference. Then, so there's our fraction of the circle, multiplied by the circumference. We can work out the arc length. That's this bit here. And that's called L. Okay? It's not an E, it's an L. And our perimeter equals the distance around the outside. So it's that arc plus 2 of the radii. Because we need to include these two things as well, because they're part of the outside of the shape. So we can do it in 2 steps. We can work it out as the length of the arc, and then we can work it out with this perimeter formula here. Or if you like, you can go straight to that formula. Doesn't really matter. Okay. So here's an example. Calculate the perimeter of the shape, sector shown below. So let's start by looking at what we have. So we're calculating the perimeter of the sector. We know that the radius there and there are both 3. So we're going to need those as part of our perimeter. This is the arc length there. And we know this is the angle. So what fraction of the circle? It's 80 out of 360. So let's look at how to work that out. So we work out the length of the arc. So that's what fraction is 80 out of 360 multiplied by 2 pi times the radius of 3. That comes to about 4.2 centimeters. So our perimeter is that arc length substituted in there plus 2 of the radii for those 2 straight sides. So that comes to about 10.2 centimeters. So there's a variety of questions you can practice on here. They're all in exercise 12a. The easier questions are in question 4 through to 9. Moderate questions where we start mixing in some compound shapes start at question 12. And questions 17 to 21 are more challenging. They're our big word problems. You may not find them difficult. Some of you might find them a bit hard to get your head around. That's okay. How do we get better at these? We practice. If you've got a fairly good grasp of perimeter, you should be starting at question 12. So that concludes